Hello and welcome back to the lecture on applied econometrics, and in this lecture we are going to talk about a very important probability distribution, that is a t distribution. Now t distribution is important because we will see in many cases, in most of the cases we are actually going to deal with unknown parameters. We really do not have known population parameters, and when we are actually trying to use the unknown parameters from sample, we use the t distribution, and we will see wide ranging application of t distribution when you do regression and other applications. So let us try to understand what is a t distribution. So when I have a population which I have a known variance for example, let us say that is sigma x, and I get the population, this is say population variance, population standard deviation. Now this I calculate from all the observations, I do not take mean, but I just calculate from all the observations. And now suppose I take mean, I want to sort of estimate the population standard deviation by taking means, and if I take means several number of times, how I actually get, what I get is a population standard deviation from all the means. Now we usually do not do that. What we do as an approximation is that we simply divide it by square root of n, and that is population SD of means. We sometimes call it standard error of means, or SCM we sometimes write it, and that sometimes we represent it as sigma x bar. Now that is for the when you know about the population SD, but most of the cases, as I just said, you do not know the population SD. So what you have to do is you have to estimate from sample. Now when you have to estimate from sample, we know we have this Sx, we write it as, or I can actually use square root of 1 by n minus 1, then I have xi minus x bar whole square. So I basically divide it by 1 by n minus 1, and we have explained the intuitive logic why I have to divide by n minus 1 and not by n. So that I get. Now that is for the you are basically getting the standard deviation where you do not have the population standard deviation known to you. Now if I want to get the standard deviation of means, so like you want to actually estimate the standard deviation from means, which is nothing but the standard error, we basically say it standard error of means when SD, when population SD is unknown. So what we do is we essentially divide it by just the same approximation procedure, 1 by root n summation 1 by n minus 1 over n xi minus x bar whole square, or I can write square root of 1 by n into n minus 1 summation all over n xi minus x bar whole square. So that is how we sort of estimate the standard error of mean for when we are actually using sample to actually estimate the standard error of mean. Now in the first case, so let me actually write down the equation. So let us say this is my equation 1 and this is my equation 2. So in equation 1 I estimated standard error of mean, but then my standard my sigma is known, and here I have estimated standard error of mean, but sigma is not known. So if I am using if my standard deviation is known, I write my z is equal to x bar minus mu 0 by sigma x square, when sigma x. So where my standard normal z is going to be this. So here this is known, but in case it is not known, then I use t, and when I use t, it is basically this by I use that Sx bar. So, Sx bar, right, it is from unknown. So, known sort of population parameter, that is unknown population parameter. Okay. So, this is basically the difference between the normal distribution and Z distribution. For unknown population parameter, you use the T distribution. Now, T distribution is widely used because, as I said, in most of the cases you do not know the population parameter in advance. Now, there are some other differences, say the difference comes in terms of the randomness. So, in this case, suppose when you talk about Z, we have this x bar which is random variable, right. It is sort of you draw samples and you get the x bar values, whereas your sigma x bar, this is given and this is like you do not have to bother about that. But in case of T, your x bar, you have, it is a random variable, at the same time your Sx bar is also random variable, because as you draw random samples, you essentially get different values of Sx bar, and that is why it keeps on changing. So, because of that, your the Z distribution, it has random variable only in numerator, and T distribution you have random variable both in numerator and denominator, and that is why the T distribution is actually a little more complex than the distribution that you get for Z, which is a normal distribution. Now, so let us write down T distribution, more complex than Z distribution, right. Now, another aspect, another property of T distribution is that T distribution is a family of curves, and what I mean by that is that the family is actually a product of the, depending on the number of degrees of freedom, numbers of degrees of freedom. So, as the degrees of freedom are changing, your T distribution will essentially change. So, for example, let us see, if I actually use a T table, you will see that your T distribution, all the different this is a T distribution for critical T values. You will see that for different degrees of freedom, you are actually getting all the different critical values. Now, how it will look like if I actually try to draw this T distribution? So, it will be like T distribution actually looks like a normal distribution, but sorry, it is going to be like this. So many different, oops, I will use a different color. So many different curves you may just have. Okay. So, it all depends on what is the number of degrees of freedom, and we will see how these distributions actually vary with different degrees of freedom. Now, as we see that T distribution is kind of similar to normal distribution, is an approximation to normal distribution. So, as we improve the degrees of freedom, as the degrees of freedom increases, the T distribution approximates with DOF increasing, the T distribution approximates to a normal distribution or Z distribution, let us say T distribution approximates to a Z distribution. Now, what happens here is that for T distribution in general, so the difference between T and normal distribution is that the mode and the tail. So, we need to remember this, the mode and the tail, where we see some differences between T and Z distribution. So, what I mean by that is that if this is a T distribution, essentially it means that my T distribution has a thicker tail and the modal value is less as compared to normal distribution, right, normal distribution. So, we see that, so the modal value for T distribution is here, whereas that for normal distribution is here, and the tail is for normal distribution is a thinner tail and for T distribution is a thicker tail. So, these are very important when we are actually going to do the significance testing. how it will be like. So, if we have a thicker tail, so it will be like, you know, the more number of observation will be on the extremes. So, that is what, like, you know, given a t distribution or normal distribution, you would prefer a normal distribution because it has a thinner tail, but t distribution, but nonetheless you have to use t distribution when you have unknown sort of you know, you do not have the population parameters not known. Okay. So, in the next lecture we are going to see how this tail, if it is a thicker tail or if it is a thinner tail, how it actually matters when you are actually doing the significance testing. Thank you.